Welcome to the FS5 service tutorial. In this tutorial we'll show you how to change the FS5 bulb and also how to calibrate the monochromators. Firstly, you remove the 4 black trim panels from around the sides of the FS5 and then you slacken off the screws and remove the left-hand section of the lid. At this point, safety glasses and gloves should be worn. You remove the 2 screws from the top of the bulb compartment. Then you remove the 3 screws holding the lamp compartment lid and remove the lid. You then remove the 2 screws holding the vertical retainer. You then remove the anode wire, slacken off the anode clamp and prise the clamp open. You then remove the bulb and remove the cathode connection. The cathode support is connected to the new bulb and the new bulb is placed in, taking care to ensure that the wire down the side of the bulb does not interfere with the beam path. The anode support is then placed on and connected, and finally the vertical retainer is screwed on, and the lamp cavity lid is then attached. We allow access to the top of the bulb to allow vertical movement and alignment of the bulb. Please consult the previous video tutorials and manuals on bulb focus. We will now show you how to go through a process to ensure that your excitation and emission monochromators are properly calibrated. Firstly, set the excitation bandwidth to 0.3 nanometers. Then go to File, New Spectral Measurement, Service Scan, Excitation Monochromator Calibration, or Control+4. We now scan over the spectral range of 470 nanometers to 480 nanometers, and we hope to see the xenon line coming in around 473.4 nanometers. In order to calibrate the excitation monochromator, we use the positions of the xenon lines, in particular the one at 473.4 nanometers. The monochromator should be kept within a calibration specification of plus or minus 0.5 nanometers. If you measure the position of the line to be outside that specification, then go to Setup, User Calibration Setup, Calibrate Excitation Grating, and you input the value that you measure for the line position, for example 471.7 nanometers, and the desired value, which is 473.4 nanometers, and press Update. You can then repeat the scan to ensure that the line position has moved. This will update the calibration settings of the excitation monochromator to ensure that the line is now in its correct position. In order to calibrate the emission monochromator, we put a scattering solution into the sample cassette, perhaps Ludox from Sigma Aldrich, or even water with a touch of milk. We now set the emission monochromator bandwidth to 0.3 nanometers and set the excitation wavelength to 473.4 nanometers and a bandwidth of around 0.5. We now perform an emission scan, as shown on the screen, from 470 to 480 nanometers in 0.1 nanometer steps. We now observe the position of the peak of the scattered light. It should be at 473.4 nanometers. If the position of this peak is out of specification, then we do a similar process to what we did with the excitation monochromator. We go to Setup, User Calibration Setup, and calibrate emission monochromator, and we input the measured peak position and the desired peak position, which is 473.4 nanometers. Again, the software will adjust the emission monochromator calibration settings to ensure that the peak position is now at 473.4 nanometers. The calibration of both monochromators is now complete.